Good morning. Now we'll study in unit number 6b impulse momentum theorem. What it states that first we will see when a force or force system acting on a particle for a short interval of time delta t or from t1 to t2, then the algebraic sum of the impulses developed by all forces is equal to change in momentum for this time of interval. So impulse from point 1 to 2 is equal to m2 minus m1. M is momentum 2 minus momentum at 1. So momentum is nothing but mass into velocity, so that is equal to mv2 minus mv1, where impulse means impulse 1 to 2 is equal to final momentum minus initial momentum. Impulse is nothing but force acting for a short interval of time. Now on the same time, when sum of the impulses forces are equal to 0, means the impulse force is equal to 0 or there is no impulse force acting on a particle, then final momentum is equal to initial momentum and the momentum is conserved. This also called as a law of conservation of momentum. Final momentum is equal to initial momentum is also called as a conservation of momentum. Now we'll solve some problem on this conservation of momentum. So first we will see some problem on conservation of momentum. So problem number 1. A boy of mass 60 kg and a girl of mass 50 kg standing motionless at the end of a boat which has mass of 30 kg. If they are exchange their positions, determine the final position of a boat and neglect the friction. Diagram is not given, but we will develop a diagram. A boat is given. On one end, a boy is mass 60 kg standing, and on the other end, girl is standing of 50 kg mass. The mass of a boat is 30 kg. The distance between them is 1.5 meter. Now, initially at everything is at the rest, so initial momentum is 0. After some time, they exchange their positions. So, due to this changing their position, that boat get displaced by a distance x, and that x we have to determine. Now we'll apply momentum of conservation. So initial momentum equal to final momentum. Basically final momentum minus initial momentum is equal to 0 because no external impulsive force is acting. So we can write initial momentum is equal to final momentum, and out of that initial momentum is equal to 0. So we'll write down 0 equal to mass of a boy into velocity of a boy plus mass of girl into velocity of a girl. Now boy is moving towards the right, so that velocity or a distance traveled is taken as positive, while girl is traveling towards the left side, so velocity of a girl or distance traveled by the girl is treated as negative. This is plus mass of boy plus mass of girl plus mass of boat into velocity of a boat. Now we know velocity is equal to distance per unit time, and that we will write the distance traveled by these two are 1.5 by t, negative sign because girl is moving towards the left, plus we are assuming that boat is moving towards the right, and that is up to distance x. So this combined mass of these three into distance x upon t will cancel out this t because in the same time this 3 are moving, so t will get cancelled out, and after that after solving this we'll get x is equal to minus 0.107 meter, and this negative sign indicates that boat is moving towards the left instead of a right. One more problem. A man of mass 70 kg is standing on the one end of a boat of a mass 300 kg and 5 meter long. He walks from one end to other end of the boat, which is initially at rest. Find the displacement of a boat when man reaches to other end. So again we will develop sketch. A man of 70 kg mass is standing. The length of a boat is given 5 meter. Boat mass is 300 kg, and this man walks from one end to other end. So due to this action, that boat get displaced off. We assume that distance is equal to x, and this x we are asked to find out this distance x. So again we'll use moment of conservation. We'll use conservation of momentum, that is initial momentum is equal to final momentum. In this case, initially everything is at the rest, so initial momentum is 0. Now final momentum is equal to mass of a man into velocity of a man plus combined mass of man and boat into velocity of a boat. We know velocity is equal to distance per unit time, so 70 into 5 by t plus this combined mass into assuming distance x as a displaced by t will cancel out, which is the same for all these two displacements, so we'll cancel out t, and after solving that we'll get x is equal to minus 0.94 meter. This means this boat is moving towards the left after the displacement of man from one point to another.